Discriminant analysis and factor analysis. Basically, these analytics methods can provide financial professions with unique insights into investment stocks, portfolios, and market trends. So let's get started with discriminant analysis. So basically, this discriminant analysis is a statistical method employed in finance to classify consumers according to certain characteristics and identify which variables best distinguish between groups. So it allows businesses to segment their audience based on the distinct features like income level, credit score, education background, etc., enabling personalized marketing approaches tailored towards meeting unique needs of diverse segments of the population. So imagine a bank wanting to differentiate between potential borrowers who are more likely to repay loans versus those who have a high probability of defaulting. So using this discriminant analysis, the lender can gather information regarding loan application, evaluate critical attributes influencing repayment behavior, and ascertain which element contributes substantially to distinguishing borrowers who pay back debts timely from those who don't. So based on these findings, the institution could craft customized lending programs specifically suited for high-risk borrowers requiring additional assistance. So while also offering competitive deals to low-risk borrowers who display impeccable payment records. So this application of discriminant analysis supports institutions to minimize risk, streamline operations, and enhance overall performance via efficient resource allocation. So to understand this better, let's understand it using a Python code. So here we are first importing the functions needed, that is the linear discriminant analysis, load Aries dataset, and accuracy score. And we also use the random state parameter inside this train test split to ensure that consistent splits across multiple runs. Then we load this Aries dataset from sklearn.dataset and separate the numerical features X and category targets Y stored in the dictionary returned by function call. Then we use this train test split to divide both X and Y into training and testing subsets, and this allows us to evaluate the performance of our machine learning model using previously unseen data. So after splitting this data set, we create a new object called linear discriminant analysis from this imported module, and this is the actual algorithm that will do the work of analyzing and separating the categories. And using the split method of linear discriminant analysis, we apply it to the training subset and prepare it to generalize to the new dataset. And lastly, we obtain this predicted output from linear discriminant analysis using this predict method applied to our testing dataset. Also, we calculate the accuracy score provided by sklearn's metrics module to see how well our trained algorithm perform. And the score measures the proportion of true positives and negative cases among all test samples, providing insights into the effectiveness of our model. And printing this value helps us understand how accurate the model was at making decisions based on this given input. Now next comes the factor analysis. Now, this factor analysis is a statistical technique commonly applied in finance to analyze and condense several interrelated variables into a small number of underlying factors that explain the majority of variability present in the data set. And this process is beneficial because instead of examining numerous variables individually, factor analysis enables analysts to understand the relation among multiple factors simultaneously, thereby providing deeper insights into the market trends and investment behaviors. So suppose a fund manager wishes to examine the driving forces behind portfolio returns over an extended time horizon. So using this factor analysis, the manager could scrutinize several financial indicators including interest rate, inflation, economic growth, political instability, etc., and can deconstruct the relation between these factors. So as a result, the study would reveal whether some variables carry greater weight than others in determining return outcomes, thus guiding investment decision-making processes. So overall, this factor analysis assists investors to reduce uncertainty, manage risk efficiently, and maximize returns through insight interpretation of comprehensive data set. So let's understand it better using a Python code. So in this Python program, we are working with historical stock price data for 5 different companies over a certain period of time. So using this pandas library, we create a data frame containing this information and then extract just the numerical data for 3 specified companies. And then this data is organized into multi-dimensional array called data. Next, we center the data around its mean and divide it by the standard deviation to ensure proper factor analysis. We use the scikit-learn library to conduct both principal component analysis and the factor analysis separately. And these techniques are used to analyze the large data set and reduce dimensionality while preserving most of the variations present in the original data set. So in our case, we set both the methods to identify two new variables or components based on this input data. So after running these analyses, we compare their outputs by printing various details, and then we generate visual representations that display the amount of cumulative variance. And by comparing the results of PC and this factor analysis, we can gain insights into which particular technique fits our model. Then we will get the results when we will run this code. Thank you.